I think you absolutely needed a calculator and you needed your formula sheet. Although some of you may be memorizing some of the formulas because you're lazy, that's, Mason, the only reason you should memorize them, because you get sick of looking them up. I'm not big on making you memorize stuff that you can just look up. So I said for each of the following, make sure that you defic for full marks. Okay. They want me to find current. Let's go blue. Oh, I forgot to do my favorite student. Who's my favorite student? I am. No. Good old Anne Surkey. She gets everything right. They want me to find this. I write that down. Why? Nick, I feel better. It's no longer blank. Then I say, okay, they told me V equals 48. They told me R equals 15. I think I'm going to go with I equals V over R. Is that right? I think. It's going to be 48 divided by 15. I think I can do that in my head because it's going to be 16 over 3.2? Yeah. 3.2 what? Amps. Now, if you got the right answer and the units, I'm giving you 2 out of 2. Otherwise, the way I mark these, I give you 1 mark for finding the correct equation, half mark for the numbers, and half mark for the answers. But if you forget the units, I take a half mark off. Okay. Number 2, how much power tells me the current, tells me the resistance. Do I have an equation that has P, I, and R in it? I can't remember if I gave that one to you. What? I do. I think I gave it to you on your sheet. It is there, Danielle, I think. I think it's I squared R. It is on your purple sheet, isn't it? Whew, I thought for a second there. By the way, you really don't need that because, Danielle, from those two, could you find the voltage? And then you can go V times I. It's a shortcut equation. It's an unnecessary equation. Josh, can you leave the hoodie off actually for me, kiddo? Thank you. I'm going to go 8 squared times 4. That's 64 times 4. I can do that in my head. 256? 256 watt? Oh, watts. Same as before. 1 mark for the equation, half mark, half mark. If you got the right answer, 2 out of 2. But this is my way of saying, Ibrahim, it's worth showing your work, because if you make a dumb calculator mistake, you can still get part marks, right? Looks like in number 3, they've told me power equals, now I have to be more careful, 6.4 kilowatts. I can't do physics with kilowatts. So this is, I think, 6,400 watts times by 1,000. Current is 32 amps. Voltage is going to be power divided by current. 6,400 divided by 32. 200? 200 watt. Gotcha. Volts. Why not 0.2? Because then you went 6.4. This is kilowatts. The equation doesn't work with kilowatts. You have to do a conversion. And so on your sheet it does say to go from kilo to regular times by 1,000. If you put 0.2, I would give you 1.5 out of 2. Okay? Is that all right? Yep. Otherwise, I would go 1 mark, half mark, half mark. So 1.5 for V equals means you didn't do the conversion. By the way, what you really did is you have an answer in kilovolts. And now you'll be careful on the test, right? That's the whole point. Make a mistake on the quiz, you won't do it on the test. All right, number 4. Energy. Okay. Power equals 1,200. Time equals 8. What word did I bold font there? Why would I have done that? What am I saying with it? Can't use hours either. So I'm going to have to go times 60 minutes times 60 seconds, which is 3,600 times 8, 26,400? You know what? I better double check that one because I'm going to use it. 8 times 60 times 60, 28,800. I forgot to carry forgot to carry an extra one. Do I have an equation that has an E and a P and a T in it and has the E by itself? I think so. Matt, I think energy equals... by the way, can you sit up? Like, all the way up? If you don't have your quiz here, I'd be sucking up to the system a little bit, right? Power times time. It's going to be 1,200 times 28,800. We are using that much energy. What are the units for energy? I even told you in the question. That was nice of me. So 3, 4, 5, 6, and 4 zeros. 3, 4, 5, 6, 1, 2, 3, 4 zeros joules. That's about how much a computer uses. Well, except that is not what appears on your parents' bill. Your parents have this... Oh, same as before, by the way. 1 mark, half mark, half mark. Your parents' bill rate is in kilowatt hours. So how do I go from joules to kilowatt hours? Energy is going to be 3, 4, 5, 6, 1, 2. I think it's divide by a 3, a 6, and 1, 2, 3, 4, 5 zeros. Is that right?
Yeah.
So divide this number. You get 9.6 kilowatt hours? That is less terrifying on someone's bill. So for this one, I would give you 1 mark if I saw that you had divided by 3, 6, and 5 zeros, and then 1 mark for the answer. There's your 2 marks. BC Hydro charges 8 cents per kilowatt hour, which is about right. I think that's the rate right now. How much does it cost to run? Well, the cost is going to be 9.6 kilowatt hours times 8 cents per kilowatt hour. I'm putting in the units just so you can see how it fits together. If you went 9.6 times 0.08 times 0.08, and this is a bit of a problem. To run a computer for 8 hours costs 77 cents. It's cheap. So this is why I said, I think, Carter, you heard me say, I don't turn lights off to save money. I mean, I do save a few cents. I turn lights off because I want to save the planet. If you said 0.768, I'll live with that, but wait a minute, dollars and cents, we round to 2 decimal places for dollars and cents. Is that right, folks? Yeah? Okay. 1 mark for the numbers, 1 mark for the answer, and now we turn the page. Well, they want me to find voltage. Okay. They gave me current, 4. They gave me power, 60. They gave me time, 40. 40 what? Minutes. You know what? I better times that by 60, 2,400 seconds. Now to find voltage, I think I can use V equals power divided by current. I think I can go 60 divided by 4. I think I can tell you 15 volts. Is that right? To find resistance, I think I can go R equals V over I. I have to use my answer from part A to find the answer in part B. It's going to be 15 divided by 4, which is going to be 7.5 divided by 2. 3.75? No? Yeah? 3.75 what? What are the units for resistance? Ohm. Ohms. Now, Cole, because you had to use an answer from part A, here's what I'll say. If you got this answer wrong, but Brian, you dropped it down here and you divided by 4 and got an answer, I'll give you 2 out of 2 for this, even though you have a different answer there, because you did this one totally right. You just got the first part wrong. Okay? How much energy does the bulb use in 20 minutes? Why did I say 20 minutes when up here I said 40 minutes? It's a little different. Okay. Well, did they tell me power? 60. And I guess time is 20 minutes times 60 seconds. I have a feeling, by the way, that this was a typo, that I meant it to be 40 minutes and just mistyped, but I'll go with what the question says. Energy is going to be 60 times 1200. 72 with 3 zeros, is that right? Yeah. 72,000 joules. Same as before. Oh, you know what? I forgot to write the equation. Not same as before, Mr. Dewick. Now I can make it same as before. E equals power times time, which equals, so 1 mark for the equation, half mark for the numbers, half mark for the answer. If you forgot to change the 20 to seconds, if you just went 60 times 20, I'd give you 1.5 out of 2. V is 120. Power equals 240. Wait a minute, Mr. Dewick, isn't that the resistance? No, it says watts. It's a 240 watt resistor, but the wattage is 240. Current is going to be power divided by voltage is going to be 240 divided by 120. Do you get 2 amps? Is that right? Find the resistance. Resistance equals V over I, which I think I know now. 120 divided by 2. Is the resistance of this resistor 60 ohms? Heat energy in joules. Well, energy is power times time. Did I get the power? 240. Why is 240 times 20 wrong? Okay, times another 60. $240 times 20 times 60. Do you get 28,000? 288,000? 288 and 3 zeros. Joules to kilowatts. That's going to be, sorry, it's not power, it's energy, is 288,123 divided by a 3, a 6, and 1, 2, 3, 4, 5 zeros, divided by a 3, a 6, and 1, 2, 3, 4, 5 zeros. Is it 0.08? Kilowatts. Kilowatt hours, sorry. Kilowatt hours. 1 mark for dividing, 1 mark for the answer. Could you please give yourself a lovely score out of 26, please? Can you make sure your name is on them? And then you can pass them inwards, and the person in the middle, put them in a nice neat pile, all facing the same way. The last day I gave you the analogy that every circuit, as long as it was closed, which I showed you open circuits on the simulator earlier, was like a ski hill. What did I say the battery was like? The chairlift. It gives you height, it gives you energy, it raises charges to a higher energy state. And the resistors are like the ski runs, and if you end up at the bottom of the battery, you have to have lost all of the voltage. What did I say the skiers were like? The skiers were like the current. The current was like the skiers. And so the first rule that I gave you was the current law. Current in equals current out of any junction. So if I have 2 amps coming in and 1 amp coming in, I'm going to have 3 amps coming out. We did some practice here. We said, okay, if I have 8 amps going down and 5 amps going to the right, there must have been 13 amps coming in. And that's how I knew that the total current in this circuit was 13 amps. And then I could track how it broke up. That was the current law. Then the voltage law said, if you end up back at the bottom of the chairlift, you have to have used up all of your voltage. And then all after that was using V equals I times R, I equals V over R equals V over I, power equals V times I, the equations, because I said to you, in anywhere in the circuit, in any resistor, if you know 2 of the things, you can figure out all 4 of the things. Okay? You all have a blank page on the back of your notes, the very last page. Can you go there, please? Okay? And you can write this down. Steps to solve circuits. On the back of the blank page. You have a blank page on the back. Okay? First thing you want to do, you want to find the voltage source and label downhill. Put arrows so that you know which way you're skiing. It takes 2 seconds, it takes less than 2 seconds. That's why you'll see I put arrows. I go through every junction making sure I know, hey, which way is downhill? I don't, Ibrahim, accidentally want to go the wrong way up the circuit, and that's easy to do in a complicated circuit. And for the whole 2 seconds that it takes, it's good bang for your buck. Also, just in doing that, Ibrahim, you'll get a good feel for how the circuit is put together, because you'll actually kind of quickly ski through the mountain in your head. Step 2, try and find the total current, and I'll put in bracket skiers, leaving the battery. I'll put in bracket chairlift. Because if you can find that, it falls apart. Trust me. Then it's just going to be hopscotching your way through the rest of the ski runs. So step 1, find the voltage source labeled downhill. Step 2, find the total current. If they haven't, Mandy, told you the total current, find any resistor with 2 things on it. 2 pieces of information. I'm going to be very vague and just say 2 things. Any resistor, Grace, that has 2 numbers on it. Because then you can, if you know 2, you can fill in other stuff, and then often you'll find, oh, one of the things that I just found helps me find the next thing in the rest of the circuit, helps me find the next thing in the rest of the circuit, helps me find the next thing in the rest of the circuit. These are my 3 steps. There is actually a 4th step that you'll learn in Physics 12. In Physics 12, if they don't give you anything, then what we do is we rewrite the circuit into its simplest mathematical form, and then you can solve it, but that's a complicated step, and I'm not going to get you into that here in grade 9. You know what? Oh, I'll even go there. Now it looks like a heading and underlined. Okay? This is for those of you who like little checklists and like to go systematically. This is how I go about things. Is that okay? Everybody got it? Yeah. Good. Let's go back to this page right here. Light bulb questions are a good test of student understanding of circuit laws. They are. Instead of me saying, tell me the current, instead of me saying, tell me the voltage, I can just say, which bulb is brighter? What affects the brightness of a light bulb? You've installed light bulbs at home. How do you know that one bulb is going to be brighter than another bulb? Not the voltage. It's the wattage. I know a 60-watt bulb is brighter than a 40-watt bulb. I know a 100-watt bulb. What do I measure in watts? Okay. The brightness of a bulb is related to the power going through it. Which means, really, if you know the voltage in that bulb and the current in that bulb, you can go V times I and you know the power. So example 9. Guys, please stop. The bulbs below are identical with a resistance of 8 ohms each. You know what? Let's add that to our diagram. I'm going to go 8 ohms, 8 ohms. Which bulb is brighter? I don't know. Let's find out. Let's go skiing, shall we? Let's. Mr. Duick says, first thing we do is we label downhill. That's downhill, that's downhill, that's downhill, that's downhill, that's downhill. That took 2 seconds. What was that? You good? And I'll zoom in so, Josh, you can see at the back a little better. Yep, there we go. Okay, we're back. Mr. Duick said step 2 was see if they told you the total current. Did they tell me the total current? No. Trevor, did they tell me any current anywhere? No, because sometimes if they tell you the current further down, you can add them together, and that happens to be the total current. But okay, so step 3, find anywhere with 2 things. How many pieces of information do I have on this resistor? 1. How many pieces of information do I have on this resistor? 1. Oh, can we solve this? You know what? We need to add one more step. You know what step 4 is? Go skiing. Oh, got too many eyes in there. Start on the battery, go in a complete loop so you end up at the bottom of the battery, and see if you can figure out any missing voltages. Let's go skiing! Drew, you ready?
Not really.
We're going to anyways. So Drew, when I go skiing, I start on the chairlift. Okay, look up, my friend, and just watch. Follow along with me. How many volts do we gain here? So we better lose 10 by the time we get back to the bottom. Ski with me, 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 ski with me. I'm going to go down this hill because this is a resistor. Did that get me to the bottom?
Yeah.
How many volts must I have lost going through that resistor? Hey, Drew, how many things do I know now? Then I know 4. How many amps must there be going through this resistor? I got voltage. I got R. I. Is it I equals V over R?
Yeah.
So 10 divided by 8, which is 5 divided by 4, 1.25? Is that right? Double check me. People need to try this on their calculators. Is 10 divided by 8 1.25? All right? Okay. So, that's not what this question asked. This question asked which bulb is brighter. When I talk about brightness, what am I really talking about? Okay. How many watts of power in that bulb? How can I figure that out? What's the equation for power? Sorry, what was that? Cool. You know what? I can even just go V times I, and that's nice because V is 10. Right? 10 times 1.25, 12.5. Yeah? Don't think so. Oh, equals power. Like power equals V times I. V divided by I is R. By the way, they're all related, so they're all going to have very similar equations because they're all coming from the same idea of electricity. Right? 12.5 watts. This is a, you know what? This is probably like a really small bulb, like a little Christmas light bulb or something like that. Drew, let's go skiing. How high? Ski with me, 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 ski with me. Whee! Ski with me, ski with me, ski with me. Did we get to the bottom? How many volts must I have lost through here? What must the current be through here? You know what? It happens to be identical, which is really nice. I don't think I put an amps there. I should have. Hey, what's the power through here? What can you tell me about both of these bulbs' brightness? And it says, explain your answer. Hey, read it and weep. I just proved it. I actually crunched the numbers. 12.5 watts each. Okay. A very similar setup in example 10, except instead of putting the bulbs... By the way, we say these two bulbs are in parallel because they're side by side. Oh, while we're at it, how many amps are flowing through this circuit grand total? 2.5 amps. Okay, now, by the way, now if I had I total, it really would fall apart if there was anything else in the circuit. But you can always get there eventually. We say these are wired in parallel. These ones are wired in series because all the same current goes through them. The two bulbs below are identical with a resistance of 8 ohms each. Which bulb is brighter? I have a feeling maybe these might also end up being the same. Prove it. Okay. Do I know total current? No. Do I know two things on any resistor? No. Well, I can label downhill. Cole, what was the equation for power that you mentioned earlier that I said we actually didn't need to use, the one that had the squared in it? Okay, let's write that up here. Put that in your back pocket for a second. All right. Do I know two things here? Do I know two things here? I do know two things here? What two things do I know here? I got 10 volts in each. Let's see. Let's go skiing. How high? How many hills are there? Now I know both of those hills add to 10. Not 10 each, because that would be getting on a 10 volt high chairlift, but somehow skiing through 20 volts to get back to the bottom. Does that make sense? By the way, it's a common mistake. Even my physics 12s want to do that one. Are there any junctions anywhere in this circuit? So what can you tell me about the current flowing through here and flowing through here? They are the same. The same. The same. You with me on that? Because all the skiers got to go down this hill. So you know what? This is going to look a little weird, but I'm going to actually just say I equals I and I equals I. The current is the same in both. Why does that let me conclude that the power must be the same in each bulb? Why does that let me conclude that the power must be the same in each bulb? Cole, can you read me this equation?
P equals I squared times R.
Do each of them have the same R?
Yeah.
Do each of them have to have the same I just because of the way they're wired? Well, if they have the same I and they have the same R, whatever numbers that I put in here, won't I get the same answer for both of them?
Yeah.
This is an algebraic one. I can't actually get much more than that at this stage. Now in Physics 12, we learned how to combine resistors into one, and we can actually do this mathematically. But for now, all I can do, Mason, is I can say, look, even though I can't tell you what their watts is, same R, same I, same wattage. Has to be. Okay? What's your homework? We're going to be watching a Mythbusters video for the remainder of class. We're going to get about halfway through it. Tomorrow we're going to be doing the circuit lab. Then on Tuesday, I have a whole bunch of circuits for you to solve using this. So your homework for now is, if you didn't do the take-home quiz, you better get that done tonight, or you want to get totally caught up.